going to discuss about atoms and molecules in your chapter 3. See, already in your previous class, you have learnt about this what is atom and laws of chemical combination. See, what is atom? See, always our Indian philosopher, that is ancient Indian philosopher as well as Greek philosophers, always they wondered about the matter and its classification. See, based on this, one of our Indian philosopher, that is Maharishi Kanal, around 500 BC, for very first he gave about that is all matter is made up of very smallest particle. That is each and every matter we can divide further and further. Finally, we will get an indivisible particle. That indivisible particle is called Parmanu. He said that indivisible particle is called Parmanu. So, do you know that is Parmanu? Anu means in Tamil it is called atom in Tamil. We can call it as an Anu. We know that. So, that Maharishi Kanal said that indivisible particle is called Parmanu. And as well as one more Indian philosopher, that is Maharishi Kanal. After one more Indian philosopher is Bhuta Satyayama. Bhuta Satyayama. He also one of our Indian philosopher. He also suggests that these particles are combined these particles are not in a free state, is combined together to make many compounds, many different forms of matter. And he suggested like that all these particles are combined together to make different forms of matter. Then as well as like these philosophers and Greek philosophers like Democritus and Leucippus, they also explained about that these particles, if each and every form of matter, if we can divide further and further, finally we will get an indivisible particle. That they named, that is Democritus named that particle is called atom, which means indivisible. So likewise, many scientists, that is many philosophers, they were made attempts to identify what is atom. So based on these, that is two scientists they gave, that is laws of chemical combination. Why they gave laws of chemical combination means because these philosophers only said that the evidence are only based on philosophical evidence. There is no experimental evidence based on atom. So Lavoisier and Proust. Lavoisier and Proust. These two scientists, they were made attempts to do the experimental evidence based on this atom. So based on that, they gave laws of chemical combination. In that, that is laws of chemical combination. That first law of conservation of mass is given by Lavoisier. You know very well, Lavoisier is the father of modern chemistry. So he gave the law of conservation of mass. What is law of conservation of mass? You know very well. In your last class only you have learned about that. That is, mass can neither be created nor destroyed in a chemical reaction. That means we can't create a mass as well as we can't destroy a mass. So mass can neither be created nor destroyed in a chemical reaction. Same like this, the total mass of reactant must be equal to the total mass of the product. You know what are reactants? The substance which take part in a chemical reaction are called reactants. Suppose if we want to do one chemical reaction, we need some substance that are called reactants. Then what are products? That reactants will give as a result. That result is called product. So mass of reactant must be equal to the mass of product. So that is called law of conservation of mass. Mass can neither be created nor be destroyed in a chemical reaction. Total mass of the reactant must be equal to the total mass of the product. So as well as one more law is given by Proust. That is, what is the name of that law? That is law of definite proportion or law of constant proportion. See, this law is given by Proust. See, what is law of definite proportion or law of constant proportion in a chemical reaction? See, in a chemical substance, the elements are always present in definite proportions by mass. In a chemical substance, the elements are always present in definite proportions by mass. So you have learned some more example also. That is, for example, in water, that is two hydrogen atoms combined with one oxygen atom. Two hydrogen atoms combined with one oxygen atom. That is H2O. So what's the ratio? That is two atoms of hydrogen, one atom of oxygen combined together to form water molecule. So in the form of hydrogen and oxygen present in 2:1 ratio. Same like this, if we will compare atomic mass means we will get 1:8. So you have learned in your previous class. So that two laws, the basic experimental, it is given the basic experimental data based on atoms. So based on that two laws, that is laws of chemical combination, John Dalton proposed one atomic theory. That only we are going to discuss today. That is Dalton's atomic theory. What is that? Dalton's atomic theory. Dalton's atomic theory. So in this class today we are going to discuss about Dalton's atomic theory, because scientists they need clear explanation about that laws of chemical combination. Based on that laws, John Dalton proposed one atomic theory. That atomic theory is called Dalton's atomic theory. See, Dalton's atomic theory. According to Dalton's atomic theory, all matter. According to Dalton's atomic theory, all matter. What are the all matter? Whether element or compound or a mixture. All matter, that is element or compound or a mixture. If anything, element also is a form of matter, compound also is a form of matter, and mixture also is a form of matter. It is all matter, whether it is element, compound or mixture. All this matter is composed of a smallest particle. The smallest particles are called, we said that it is atom. All matter, whether it is an element, compound or a mixture, all matter is composed of a smallest particle. The smallest particle he called it is an atom. So based on this, he gave some postulates. So now we are going to discuss about the postulates of Dalton's atomic theory. So what are the postulates he gave means? That is his first postulate, all matter is made up of very tiny particles called atoms. Listen carefully. See, postulates of Dalton's atomic theory. This is first postulate, that is all matter is made up of very tiny particles called atoms. He said that all matter is made up of very tiny particles. The name of the tiny particles he called it as an atom. Next postulate, atoms are indivisible substance. Atoms are indivisible substance. That is are indivisible particles. Atoms are indivisible particles. He is telling atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Listen, next postulate, atoms are indivisible particles which cannot be created or destroyed. Which cannot be created or destroyed in a chemical reaction. Atoms are indivisible particles. We can't divide further and which cannot be created or destroyed. See, you know very well, atoms we can't create the atom as well as we can't destroy an atom during chemical reaction. So, see, atoms of one atom can be changed in the question. So, we can transfer the atoms. We can transfer the atoms to one place to another place. We can change the atoms in the form of energy. We can change the atoms in the form of energy, but we can't create the atom or we can't destroy the atom. So, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms are indivisible particles. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. And the next one, atoms of a given element. Atoms of a given element. That means atoms of given element. That means same element. Or that is identical element. Atoms of given element are identical. Atoms of given elements are identical in mass and chemical properties. Listen. Chemical properties. So listen. This is next postulate. Atoms of a given element, that is same element, are identical in mass and chemical properties. See, according to his postulate, he is telling that atoms of same element. That means, for example, if we are taking iron as one element, sodium as one element, like that. If he is taking iron as one element, he is considering iron as one element. Again, he is considering the same element. So, if you are taking this iron also one element, this iron also one element. So, he is considering like the same element. He is telling that same like these same elements have similar, that is identical in mass and also in its chemical properties. That means this element also iron made up of iron. This element also is made up of iron. So both also same element. So he is telling same element means they have identical in mass and chemical properties. So if we will consider the mass of this iron and also this iron, both also he is telling it is identical in mass and also the chemical properties also same because these are same elements. So that is his next postulate. Atoms of a given element are identical in mass and chemical properties. Atoms of a given element are identical in mass and chemical properties. And his next postulate, atoms of different elements. What is his next postulate? That is atoms of first we have discussed about same element. Now we are going to discuss about atoms of different elements. Atoms of different elements. Atoms of same elements are identical in mass and chemical properties, same like this. Atoms of different elements have different mass and chemical properties. Different mass and chemical properties. Listen. See, atoms of different elements. For example, if you are taking two different atoms, that is two different elements. If you are taking, instead of this, if you are taking suppose iron as one element, and chlorine as one element. So these two elements are different, isn't it? Iron also is a different element, chlorine also is a different element. Like this, if you are choosing these two different elements, I is telling that it has different mass and different chemical properties. Because these two elements are different, So he is telling that mass also it is different and chemical properties also different. This is his next postulate, that is atoms of different elements have different mass and different chemical properties. This is your next postulate. Atoms of different elements have different mass and different chemical properties. And we will discuss two more last. Before that, listen once again. Dalton's atomic theory. This based on Dalton's atomic theory, all matter whether it is an element, compound or a mixture is composed of smallest particle, it is called atom. Based on this, he gave postulate. In that first postulate, it is all matter is made up of very tiny particles called atoms. He is telling that all matter, if anything, all matter is made up of very tiny particles. He is calling the tiny particles called atoms. And the next postulate, atoms are indivisible particles, that means which cannot be created or destroyed in a chemical reaction, which cannot be created or destroyed in a chemical reaction. And then atoms of a given element are identical in mass and chemical properties. That means if you are taking two same elements, the elements have similar in mass as well as similar in chemical properties. As well as is telling that atoms of different elements have different in mass as well as different in chemical properties. And we are going to discuss about next postulate. Listen. Atoms combine in the small whole number ratio atoms combine in the small whole number ratio or in the ratio of small whole number, both are same. In the ratio of small whole numbers, both also same. In the ratio of small whole number to form compounds. Listen, atoms combine in this ratio of small whole number. Atoms combine in the ratio of small whole numbers to form compounds. Atoms combine in the ratio of small whole numbers to form compounds. That means if two or more atoms combined in the ratio of small whole numbers and it forms compounds. For example, see here it is carbon dioxide, isn't it? See, this is one compound. In this carbon dioxide, what are the elements are present? See, what are the atoms are present? Carbon is present and oxygen is present, isn't it? Carbon atom is present and then oxygen atom is present. See, this carbon atom and oxygen atom. What is the mass of this carbon atom? Do you know this? This is 12. What's the mass of this oxygen atom? It is 16. What's the mass of oxygen atom? It is 16. How many oxygens are present here? 2. That means CO2 would have 2 oxygen. So 16 into 2. That means 12. It is 32. Suppose simplify this. 6 to 12. Same like this. Here 1. Then 12. 6 to 12. And then how will you divide further? 3 to 6 as well as 8 to 16. So listen here, this carbon dioxide. This is carbon dioxide, one compound. In this atoms, that is atoms made of carbon and oxygen here. Atoms of carbon and oxygen combined in the small whole numbers to form compounds. So atoms combine in the ratio of small whole numbers to form compounds. So this is the next postulate. or else we can say that hydrogen H2O. How many hydrogen atoms are present here? 2. How many oxygen atoms are present here? 1. See, in the form of a ratio of atom, we can say that 2 atoms of hydrogen, 1 atom of oxygen is present. By mass, if we are telling it is 1:8. In this way, carbon dioxide also 1 carbon, 2 oxygen. In this way, atoms combined in the small whole numbers to form compounds. To form compounds. And then his next postulate, listen, his next postulate, the relative number and kinds of atoms are constant. Are constant in a given compound. Listen. Next postulate. The relative number and kinds of atoms are constant in a given compound. This is last postulate. The relative number and kinds of atoms are constant. Same like this. What we have discussed, that is relative number and kinds of atoms are constant always in water. The water, hydrogen and oxygen present in 1:8 ratio by mass, isn't it? In water, always the hydrogen, mass of hydrogen and oxygen present in 1:8 by mass. Same like this in carbon dioxide, 3:8 by mass. Likewise, the relative number and kinds of atoms are constant in a given compound. Always the number of atoms, that is, and kinds of atoms are always constant in a given compound. This is next postulate. See, these are postulates of Dalton's atomic theory. What are the postulates we have discussed? That is, all matter is made up of, that is, tiny particles called atoms, and then atoms are indivisible particles, that is, cannot be created nor destroyed in a chemical reaction. Same as well as atoms of given element, that is, same element has similar in mass and its properties, chemical properties, and atoms of different elements have different in mass and is different in chemical properties, as well as atoms combined in the ratio of small whole numbers to form compound. Atoms combined in the small whole numbers to form compound, as well as the relative number and kinds of atoms are constant in a given compound. These are postulates of Dalton's atomic theory. These are postulates of Dalton's atomic theory. See, based on his theory, I'll ask a question to you. Which postulate of Dalton's atomic theory? Listen carefully. Which postulate of Dalton's atomic theory is the result of laws of conservation of mass? Which postulates of Dalton's atomic theory is the result of laws of conservation of mass? How will you say that? Which postulate? And very first we have discussed that atoms are indivisible particles. Atoms cannot be created nor destroyed in a chemical reaction. What we have discussed in laws of conservation of mass, that is, mass can neither be created nor destroyed in a chemical reaction. Here he said that atoms cannot be created nor destroyed in a chemical reaction. So that laws, based on that Dalton's laws, result of the laws of conservation of mass, as well as which law of Dalton's atomic theory, that is, which postulate of Dalton's atomic theory is the result of the law of definite proportion or the law of constant proportion. So which postulate is the result of law of definite proportion? See here, finally, the relative number and kinds of atoms. the relative number and kinds of atoms are constant in a given compound. So this postulate is based on the law of which law? Constant proportion or definite proportion. Is it clear? So these postulates are Dalton's atomic theory, that is based on Dalton's atomic theory. John Dalton proposed all these postulates, and now we are going to discuss about the advantage of Dalton's atomic theory. See, what is the advantage we have? Do you know? See, this John Dalton, this postulate could explain the existing laws. This Dalton's atomic theory, based on his law, based on this Dalton's atomic theory, could explain the existing laws at that time. Dalton's atomic theory could explain the existing laws at that time. Like law of conservation of mass and then law of definite proportion. This is the advantage of Dalton's atomic theory. And now we are going to discuss about the disadvantages. See, one more advantage also we can say that this Dalton's atomic theory proposed the concept of atomic mass. Now here we have discussed atomic mass based on this. What's the atomic mass for carbon? 12. What's the atomic mass for oxygen? It is 16, like that. That is, so we can say that this Dalton's atomic theory proposed the concept of atomic mass also. Dalton's atomic theory proposed the concept of atomic mass also. About that we will discuss later. Now we are going to discuss about disadvantages of Dalton's atomic theory. See, what are the limitations we have in this? Do you know that what are the limitations you have in this Dalton's atomic theory? You have some limitations. What he said at very first, he said that atoms are indivisible particles. But nowadays, we know very well, atoms can be further divided into some subatomic particles like protons, electrons, as well as neutrons. See, John Dalton, he said that atoms are indivisible particles. But nowadays we know very well, atoms can be further subdivided into some subatomic particles like protons, electrons and neutrons. So this is the main drawback, that is limitation of Dalton's atomic theory. This is one of the main limitations. Atoms can be, that is what she said, atoms are indivisible particles, but now it can be divided. Now atoms can be divided. Okay. Then, and one more, he said that, what is this? Atoms of the same kind. Already we have discussed, atoms are same kind. Given element are identical in mass and its properties. He said that atoms are same element. Have same in mass and its same in its chemical property. He said that. But see, nowadays atoms have the same elements like chlorine. We are taking one more chlorine. Suppose atomic number of this chlorine is 17. And what about this masses means? One chlorine mass is 35 and another chlorine this mass is 37. So, based on Dalton's atomic theory, he said that atoms of same element which have same mass and same chemical property. But see, this also chlorine, this also chlorine. Both also same elements. But see the mass of these two elements. Both also chlorine, but the mass is slightly differ. But he said that is similar in similar elements have similar mass and similar chemical property. But these two elements slightly different in their mass and its properties. So that law also one of the limitations. That postulate also one of the limitation. And one more he said that is atoms of different elements have different in mass and its properties, isn't it? Atoms are different elements have different in mass and its properties. See, for example, argon is one of the atoms. Okay, atomic number is 18. Same like this, calcium also, it is atomic number 20, this one element. And this argon atomic mass is 40 and calcium also atomic mass is 40. And what is his law said that is based on his Dalton's atomic theory, based on Dalton's postulate, atoms of different elements have different in mass, but see here, these are different elements but both also have similar in mass. So this is also one of the limitations. So based on Dalton's atomic theory, he proposed some postulate. In that postulate, he said that all matter is made up of a smallest particle, it is called atom, and then atoms are indivisible. But nowadays we know that atoms are divisible. It can be divided into subatomic particles like protons, electrons, as well as neutrons. So this is one of the limitations. As well as he told that is atoms of the same element which has similar in mass, but here we have different in mass. So this is also one of the limitation. And atoms of the different elements have different in atomic mass, but here we have similar in atomic mass. So this is also one of the limitation. So these are postulates of Dalton's atomic theory, and also these are limitations. And what is the advantage we have discussed? That is, he could explain the existing laws at the time. Dalton's atomic theory explains that he could explain the existing laws at that time. As well as based on this Dalton's atomic theory, he proposed the concept of atomic mass. Dalton's atomic theory proposed the concept of atomic mass also. So that are advantages. These are the disadvantages. That is limitations. Next, we are going to discuss about what is atom. What is atom? Listen. We are going to discuss about what is atom. So listen. Next, we are going to discuss about what is atom. See, do you know what is atom? That the scientist said that it is made up of very, very smallest particle. Do you know? See, this is a wall, isn't it? See, in this building, it is made up of what type of particle? We know that very well. The building is made up of small bricks, isn't it? See, this consider, suppose for example, consider this wall. Consider this wall. This wall also, it is made up of many small bricks, isn't it? It is made up of many small bricks, and that brick is the building block of this building, isn't it? That brick is the building block of this whole building. Likewise, suppose if we will take this chalk piece, what will happen generally? If we will take this chalk piece, this is one form of matter, isn't it? This is one form of matter. Suppose I will break this chalk piece into two pieces. Likewise, I will break further and further. Finally, I will get a very small particles that cannot be further divided, isn't it? That smallest particle, as we are telling it, is an atom. Same like this, if any kind of matter if we will take, that particles finally, whether it is made up of very smallest particle, that smallest particle is called atom. So the whole world in this, it is made up of matter. So all the matter, it is made up of smallest particle, it is called atom. So without atom, there is nothing in this world, isn't it? Same like this, atom is the very, very, very smallest particle that can take part in a chemical reaction. Atom is the very smallest particle. It is the very smallest particle which take part in chemical reaction, which take part in chemical reaction. Atom is the very smallest particle that take part in chemical reaction. It's called atom. It's called atom. See, we know very well nowadays we can divide the atoms into some other smallest particle. See, we are telling this atom is made up of very, very finest, smallest particle. Then how will you measure this atom? Can you see this atom with the help of naked eye? No, we can't see. See, we can't imagine the size of atom. Even we can't imagine the size of atom because it is made up of very, very smallest particle. So even we can't see this with the help of even under powerful ultra microscope. So then how will you measure this atom? Means with the help of very smallest unit only we can measure, like nanometer. Like nanometer. See, so 1 nanometer, do you know 1 nanometer? Nm is nothing, it is nanometer. It is nanometer. 1 nanometer is equal to 10 to the power 9 meter. That means, how would like be? It is 1 by 0, 0, 0, 0, 0, 0, and finally 1 like that. It is 10 to the power minus 9 meter. Not plus 9, it is minus 9 meter. So very, very small. We may not be able to see them. We may not be able to see them. Likewise, this is very, very, very smallest particle. So 1 nanometer is equal to 10 to the power minus 9 meter. Nowadays, through modern technique, we can see the magnified image of atom, but not the exact image. Just through our modern technique, we can see the magnified image of atom. We can see the magnified image of atom. So, this atom is very, very small. The size of atom we will mention with the help of, that is nanometer. That is atomic radius we will measure in the form of nanometer. That radii, that means radius in the plural form we will say it is radii. So, atomic radii of, do you know that? Hydrogen. Do you know what is hydrogen? It is a one element. The atomic radii of hydrogen is 10 to the power minus 10 meter. It is 10 to the power minus 10 meter. Do you know ant? Ant has the size, atomic size, it is 10 to the power minus 2 meter. 10 to the power minus 2 meter. Do you know watermelon? Do you know watermelon? The atomic radii of watermelon is 10 to the power minus 1 meter. Atomic radii of watermelon is 10 to the power minus 1 meter. Do you know grain of sand? The grain of sand. The atomic radii of grain of sand is 10 to the power minus 4 meter. See, likewise, each and every smallest particle we can measure with the help of nanometer. Nanometer. So, atomic radius will measure in the form of nanometer. The hydrogen atom has that radius which is 10 to the power minus 10 meter. And likewise, ant, the size of ant, you know that it is very, very small. That is 10 to the power minus 2 meter. We can see with the help of our naked eye. That is 10 to the power minus 2. That means it is 10 to the power minus 10 means, see how many times it is more. It is minus 8 times. So it is too small. We can't see with the help of our naked eye. And grain of sand has 10 to the power minus 4 meter. Likewise, each and every smallest particle we can measure the radius with the help of nanometer. The help of nanometer. That is 1 nanometer is equal to 10 to the power minus 9 meter. 10 to the power minus 9 meter, or 1 by 10 to the power 9. 1 by 10 to the power 9. So, very smallest particle, atoms are very smallest particles that take part in a chemical reaction. See, all these atoms, we can't keep these atoms, the name of the atoms in our mind. So, for that, we have to use some symbols, isn't it? We have to use the shortest way. We have to use in the form of shortest way. We have many atoms like hydrogen, oxygen, nitrogen, carbon, sodium, magnesium, gold, silver, like this. We have many atoms are there, isn't it? Naturally, we have many atoms. So all these atoms, we can't keep it in our mind. So for that, very first Dalton proposes some symbols for this atom. Do you know what is mean by symbols? Do you know what is mean by symbols? See, symbol is nothing. It is the shortest way. It is the shortest way of representing an element. It is the shortest way of representing an element. It's called symbol. So, generally, with the help of symbols, very first, John Dalton only proposed some symbols for elements. For example, this symbol is he used for hydrogen. This symbol he used for hydrogen. And this he used for carbon. And this he used for oxygen. This he used for oxygen. And likewise he used this for what? Iron. This is for iron. And inside C, this he used for copper. For what symbol he used like this? Copper. Okay. And then inside like this L, he used this for lead. He used the symbol for, that is inside L, it is lead. And then inside it is S means he used this is for silver. He used this is for silver. Same like this. And he used it for sulfur. He used like this, sulfur. And then phosphorus, he used like this. This he used for phosphorus. He used for phosphorus. And for gold, he used the symbol like this. This is for what? Gold. And then platinum, he used like this. Platinum. So same like this. This symbol he used for mercury. He used for mercury. Like this, John Dalton very first used some symbols for elements. See, this is for hydrogen, carbon, and oxygen. This is iron, copper, lead, sulfur, silver, phosphorus, gold, platinum, and mercury. And likewise, he used some symbols. See, these symbols also, we can't keep it in our mind easily. So, after this, one more scientist, Berzelius. One more scientist, who's that? Berzelius. He gave the symbols. Who's that? Berzelius. He gave the modern symbols by using with the help of first letter with other letter as used as a symbol. For example, he here used hydrogen. How will you name this hydrogen? You know that this is one of the elements. So this hydrogen, this is the full form of hydrogen. And how he gave the symbol for hydrogen is he chose first letter as a symbol. As well as suppose whether it is helium. He took first two letters. In that first letter is capital letter and second letter is small letter. The capital letter want to write in uppercase and small letter want to write in lowercase. Like this. And first letter with another letter he used as a symbol. It is given by Berzelius. That generally we can't give a name of the elements generally with the help of and that is like the Dalton symbol, like this symbol. Nowadays we have a naming system is there, that is IUPAC. We have one naming system with the help of IUPAC only. We will give name for all the elements. That is IUPAC nothing. International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. This is IUPAC. With the help of this IUPAC only, we can name all the elements and also all the compounds nowadays. So this is the systematic way of giving naming system, and IUPAC, International Union of Pure and Applied Chemistry. So systematically nowadays we are giving names to all those elements with the help of IUPAC only. So that element symbol is used as a first letter, or first letter with other element is used as a symbol. For example, hydrogen, the first letter is used as a symbol. Always first letter we have to use capital letter, need to write in uppercase. And helium, the first letter already hydrogen we choose for H, and this is we are taking for first two letter, it is He. So first letter capital letter, second letter small letter. First letter you have to write in uppercase, and second letter small letter you have to write in lowercase. Same like this for aluminium. For aluminium, what is the symbol for aluminium? That is first letter capital and second letter L, aluminium. Then we have cobalt. How do you write this symbol? It is you have to write C cap O small. Or else you will write CO like this. This is not cobalt. C also cap, O also cap. This is carbon monoxide. This is a compound, not an element. So element always we have to give the symbol with the help of first letter is a capital letter and second letter is a small letter. First letter we have to write in uppercase and small letter we have to write in lowercase. Okay, this is the symbol for element. What is mean by symbol? Shortest way of representing an element. See, nowadays we have 118 elements are there. All the elements we can't keep it with the help of, in our mind, with the help of full name. So we have to use the shortest way with the help of symbols. For that, we can choose the first letter or first letter with other letter as used as a symbol. And some elements we can derive the name from Latin name also. For example, a Latin name we will use for sodium. The symbol is Na, because the Latin name of sodium is natrium. What's the Latin name? Natrium. So we are choosing Na, that is from Latin name. So the sodium symbol is Na. Same like this, potassium, the symbol is K because Latin name is kalium. Same like this, gold, RSAU. Silver, it is argentum, it is Ag. We are taking silver, it is argentum. We are taking the first letter and third letter, it is Ag. Because AR, already we have argon. So this is Ag, is the symbol for silver. Like this, a symbol is nothing. The shortest way of representing an element by using the first letter or with other letter. So always we should use first letter as a capital letter and second letter as a small letter. This is the way of writing symbols. Okay, children. So listen what we have discussed today. We have discussed about Dalton's atomic theory, and we have discussed about the advantage of Dalton's atomic theory and disadvantages of Dalton's atomic theory, and what is atom and what is symbol. So remaining we will discuss in our next class. So before that, you have to go through the periodic table. In that, at least you have to know the symbols and symbols for at least 40 elements or 50 elements you have to know now. So just see your periodic table and go through your symbols in the periodic table. Remaining we will discuss in our next class. Thank you, children.